Data going out. See if we can get, let's see if we're getting a stream. Have a mobile dashboard. And audio, perfect. How do I get back? There we go. Back to the dashboard. Okay, so back to another week. Last night, I don't know if you may or may not have noticed, I got a few more followers because coming over from CJ's channel, Coding Garden. So thank you, CJ, for having me on. It was a super blast to go on there and create a little breakout game with you. And if you watch that and you end up making some breakout games or anything, please at me or tag me on Twitter with a like a link to the game. I'd love to check it out. Okay. So we're continuing on with our learning Rust this morning, and we're on chapter 8, and we've kind of been doing like the same exercise but in different ways. First, I just used functions, then I used an enum, or rather, it's not really enum. I wanted to use an enum, but that made it a little bit too hard. Instead, the appropriate way to do it apparently was a tuple structure. So that's what I did. And now, if you come over to the code, now I want to sort of take our tuple structure and just put this into a library, and that will allow us to export a lot of this out. So let's really quickly go over the code of what we've got right now before I start doing that. So we have we're bringing in hash map because we are using that in one specific place. And the problem itself is, given a list of integers, use a vector and return the mean, which is the average value, median, which is the middle position, the mode, which is which one occurs the most often. So we have in our main function, it's very simple now. We just create our list, and then we pass, then we just have our 3 prints, which we say like, hey, this is the mean of the list. And we instantiate a list off of the structure numbers. And then we could just call mean, median, and mode off of that. Now, off of here, we had attempted to do enum. That didn't work. So instead, what we have are this basic structure numbers, which takes a vector i32, which is a tuple struct. And then we have an implementation of numbers. So I don't know if that's exactly the right way to say it, but this allows us to put these functions on numbers here. So we have function mean, which takes in a reference to self, which, I mean, sort of like this in JavaScript or in many other languages, if you're talking about like class-based type stuff. And it returns a floating 32-point number. And here it's just, okay, we use the built-in iteration methods. So it's like, hey, let's create a sum, which is going to be an i32, and we take self, and self.0 is the actual list itself. And then we call the iteration method, which returns an iterator, and then that itself has a sum that we can use. So that just sums up all the numbers in the array, or vector rather. And then we just return sum as f32 divided by, the full length. Median Median also takes in self, but this time it takes in a mutable version of self. And the reason we do that is because we need to sort the vector. But once we have the vector sorted, then we're able to get the middle index. Well, this gets really interesting because in the median, if it's an even number, there is no single middle. There's two. And if there's two middle numbers, you have to then get the average of both of those, and that is the median. So what we ended up doing was used match here, and Avers last time helped us out do that. Match, which basically we say like, hey, self, get the length modulus 2 to let us know is if it's 0, well, clearly it's even. Otherwise, every other possible answer is odd. So we're able to then do the code here, which is, okay, get that middle index and just return it. Or get the middle index, combine like that one plus the one next to it together, divide by 2, and then return that. And the mode is take in reference to self, declare that we're going to return and a 32-bit integer. And then we're going to instantiate a hash map. And the hash map is very similar to like an object in JavaScript. And here we just iterate through the numbers and we add things into the hash map. And we get these very interesting methods here. So if we use entry, where we give it the number we want to put in as the key, if it exists, we then get to run this and modify. And this is a callback. Sort of like a callback or a lambda. Basically, or I think the exact term is closure here, which is we take and count and we return, then we run this. The asterisk is dereferencing because we get a reference to count here. But of course, if it doesn't exist, we insert this. Then at the very end, we initialize 2 new variables, we iterate through the entire hash map, and we figure out which one has been used the most, and then we return that one. And so that's our entire, that's the entire program that we have right here. So what I want to do next is take this structure numbers and its implementations and move it into a library. And now, then, what that will allow us to do is in our library, we just have to pull in, in the main function here, we just have to pull in the library and use numbers. Now, I've just gone through the book for libraries, but I forget like the exact ways to do that, but that's the reason why we're doing this here. So what I want to do is come back to the Rust book. Rust book. I have also seen on Reddit that the Rust book has been sent to the printers. So I think it's actually it'll be available for like the printed version very soon, if not already. Okay, so what we want is libraries. So there are modules, mod and a file system. Is that the one we want? It might be. I think it is. So somewhere in 7 here. So I believe what I want to do, okay, so right, so here we're going to create a library, and that just creates like source librs. Now, if we take a look at our tree here, we have source main rs. So if I come into here, I can create a lib.rs. Now, of course, like that doesn't mean we fully have a library, but we can sort of start playing around with that. Now, they give us a test by default. I'm not going to use that. Okay, so we want to be able to say like module definitions for a community. That starts with the mod keyword, so we could just do like mod whatever. Well, that gives us functions from there. Can I do like a structure creation in a library, or do we have to do that outside? So that might be a good question for Google here. So Rust structure in library. Because I wonder if it might be that I could create like put that in a function that I call that and returns the structure. So this is creating. So a lot of these are about functions though. So do I want to, let's see, Rust library structure abstract? Not exactly the right words to like put in here to find the like the articles that I really want to get. Okay, so so these are just like code examples in different libraries. So many things in here. Okay, so what I might want to try is just throw this in here. Because if I do like mod for this struct, does that need to be a function? Like, can I just take this entire thing, cut it, place it into here, and then essentially mod numbers. I think it's like that, right? And then we move these in. And then I need to fix the indentation. Oh, you didn't work. Hold on. Re-indent lines. You did not work at all for me. Okay. Indent. There, that's closer. But I don't know if this will actually like work if I have like struct numbers in here. Because all the examples that we've gotten so far are for like functions and not structures. Because that's what I would really love to see is, okay, so there's these systems. Are there any structures like that are people just putting in here? Okay, so there's, oh no, those are not necessarily what I want. Applications, yeah, these are all like the full applications here. What I would really love to see, and maybe it can be in a book, all of these have been functions so far. So that's just creating like setting up the files are. Yeah, and these are just using connect like that. I wonder if I could do that, where if I just say like, okay, pubmod client. So if I also make this public, although I think it already is public on its own, and I just say like we have struct numbers and implement these numbers. I wonder if I could. I should probably rename this because like numbers, that seems a little bit odd. So data structures. This is a rebuilt computer, so I don't actually know if Rust, the compiling stuff is in here. Last time it asked me if I wanted to put it in, but this time it did not. But this is a brand new installation here. So if I have pubmod data structures and then struct numbers in here, can I use that? So use, and I also need to remember how to bring that in. So in our main function, this is function name, pubmod a. Okay, so this is main RS. Oh, but that's just in like the same file. That's not what I want. Now we'll use grab it from the library. Now I know I actually did. Okay, so in LibRS we have mod test. Okay, I don't think that's really super helpful there. Let's come back here and go take a look at what we have. It was in chapter 7, right? Communicator and example. I have no idea which one. So communicator, they're both at pretty much the exact same time, timestamp. Should make that a little bit bigger. Okay, so if I want to check out communicator, for example, go into source. We have a main RS and we have a lib RS. So if I cat the main RS, use communicator client, extern create communicator. And if we take a look, I guess that's what lib was, right? Because if I cat lib RS, well, it doesn't say, well, okay, so communicator is the name of this, I guess, crate. Extern create communicator, use communicator client, and here is client. Okay, so maybe we can based on that. So what was it? It was extern create. Extern create. Well, it's like this is the name of the thing. What did I call this? It is list of numbers. Is that really like all capitalized too? No, it was just list of numbers uncapitalized. So extern create list of numbers. And we can sort of see here, okay, if we continue on, extern create communicator, use communicator, and then whatever I want to do that is. So can I say use list of numbers, and inside of here it's going to be data structures numbers. Okay, so that gives me, then theoretically, will this just work for me? Now I shouldn't need to use standard collections hash map here. Instead, I will probably need that in lib. So right up here. So let's see what happens if I run this. Cargo run. I'm not in the right directory. Cd into list. Cargo run. Use of undeclared type or module hash map. Okay, so I was hoping that bringing that in would bring that in for me. It did not. Unused import. I attempt to use it right here, and I attempt to import it right here, but it didn't like my import at that point. So it did seem like it is actually trying to do it, like trying to bring in this library, that is nice. I wonder if I have to actually put it inside of this module. Let's try it again. Okay, more errors. Struct is never used. Numbers. Expected one of : semicolon or as found function. Source main rs line 6. Oh, interesting. So it didn't like my function main, probably because I've missed semicolon right there. Okay, let's try it again. Struct numbers is private. Okay, so we need to come back into here, and we have struct numbers private. Can I do pub struct? Okay, method is never used. Mean. Okay, so now we're inside of the implementations. Expected function found struct numbers. So let mute list equals numbers. Oh, interesting. So this is like attempting to set up constructor is not visible here due to private fields. So I wonder if I need to make all of these, can I just say public here? Public not permitted here because it's implied. Okay, you're implied. Do I need you to be public? Okay, so same problem here. So methods never use median and mode. Module data structures should have snake case name such as data structures. Okay. You need to be data structures. And I think that you all need to be pub 2. So that gives me here. Now, when we come in here and do data structures numbers, so you are going to be data structures. Expected function found structure numbers. Constructor is not visible here due to the private fields. Now, so I did say that this is using struct numbers. And I wonder, do I need to say like data structures numbers? Even though I did, like, I am trying to pull it in from the library. Like, would it be better if I just say I pull in use list of numbers data structures, and then I use oh, you are too loud. Where's my volume? There you go. Then I put in here data structures. Is it colon? I think it's colon. Use of undeclared type or module data structures. Oh, that's because it's misspelled. Tuple struct numbers is private. Okay. So you're private, but I'm trying to make you public. Definitely trying to make you public here. This might be one of those things where I need to go ask one of the other Rust developers I know, like, how am I supposed to do this? Because the book so far only explains how to use libraries with functions. And I don't think that you can return a struct, right? I guess I could have a function that returns this structure. That might be interesting. So if I have public mod data structures, it uses this. I wonder if I make this not public. So I implement these. If I don't make these public, what I'm curious as to if I now have a function in here that implements numbers, so it takes in. So let's say, what if I have a function called generate numbers? This should probably be a pub function generate numbers, or initialize. We'll call this init. And it's going to take in a vector. So what is that? It's going to be a, I'll call it numbers, but it's going to be a vec of I32s. And it's going to return numbers. Okay, so if I do that, then we're going to just take in a vec. We're just going to call numbers and pass it in. This is getting too confusing here. I don't want to call this numbers. I'll call this like list. And pass in list and just return whatever this gives us. Because that's going to be similar enough to right here, right? So we're just passing in this. Mute list equals, then we have the data structures. So if I do data structures and then I want to really bring in init, now I can call init this vector and see if it actually properly comes back to me. So private type data structure numbers is in public interface. Okay, so we definitely want to publicize, to make public numbers, which means they're going to need to make these public too. because they're going to be called by the main function. Okay, let's try that. Hey, and we got it. Okay, so let's take a look at what we did. We cleaned up our main function here quite a bit. So instead of having our entire data structure out here, we're putting that into a library. Then all we have to do is list like what is our external crate that we're using, and it happens to be this entire one itself. Now I guess I could like create a completely different project and pull that in, but in this case, if we take a look at their files, we named this list of numbers, which is why we're able to use extern crate list of numbers. Then we just say, okay, well, I want to go into list of numbers, which is this library, like the folder, and I want to go into data structures, which is the public module that I created in the library, and then inside of that, there's a function in it. K/. Welcome to the stream. Thanks for stopping by. And good morning. We have, okay, so it's numbers. We then just pull in this function. So we're not using it yet, we're just making it available. And then in our main function, we create our list by running that init function and passing it in the vector. The list here is now mutable. And now what that means is that we can now run these methods off of it. Now, it makes this main function really, really, really simple. Like this entire file now is just super easy to look at. All of the actual work has been relegated out to this library. So we have our public module data structures, and we just put into a block there. And here's where we say, use standard collections hash map. We found out that if we put this outside of here, then it's not going to be available inside of this block. Then we're going to say like, hey, here is our structured numbers, but we have to make this public because this public function is going to be using it directly. Then we have our implementations, and we need these to be public as well. So that way, when we call these functions directly from the main function, they're allowed to be used. But what this really means for us is that we abstract this all away into its own file and don't have to worry about it until we really want to. And that's the reason why this now works the way we want it to. All right, so let's come back in here. Going to add these in to changes, and we're going to say storing the numbers tuple struct in a library. Failed to execute get. Okay, lovely. In that case, let's just do that via the command line. To be committed, so commit -m. Okay, so storing the tuple struct in a library. Oh, right, because I haven't done this. I will push these up right after I finish. This is like a brand new build of this computer, so there are some of these things that I haven't done. But I'll go ahead and get that set up and push up right after I finish the stream. All right. So that was the first of these projects, this list of numbers. So let's go ahead, let's come back out here and take a look at what we have in our README. So we just did this, refactor into a library. So I actually want to vim. Oh, okay. VI, there we go. So you're done, we remove you. Okay, convert strings to Pig Latin. The first consonant of each word is moved to the end of the word, and A is added, so the first becomes erst fe. Words that start with a vowel have hey added to the end instead. Apple becomes apple hey. Keep in mind the details about UTF encoding. So let's go ahead and grab this. This is definitely going to be an interesting one, because I'm not really sure what methods we're going to be doing to like iterating through the strings. And we can use strings with a capital S, basically the strings that get added to the heap, so we can change them in place, or we can use stirs and then just basically be creating new strings. All right, so oh yeah, I probably did want to update that. You go away, save you. Okay, so in Learning Rust, we're going to go into chapter 8 again, and we're going to cargo new. What will we call this one? I think we're going to call it Pig Latin. Okay, so I can go to Pig Latin and code dot here. And we can go to source main. Perfect. So we start with this hello world. That looks really small on your end. Let's make that a little bit bigger. So let's begin by putting in what it is that we're working on here. So obviously we won't be able to finish this this morning. It'll probably take us, a few days to get to it, because first we have to figure out what is going to be our strategy for this. So convert strings to Pig Latin to first consonant of each word. So that sounds like, let's say we have a let our sentence is going to be equal to essentially hello world. So if I have something like this, I want to loop through each of the words. So I'm going to want to split it, and then I can iterate through that. And then for hello, this is going to become the first consonant of each word is moved to the end, so A is added. So words that start with a vowel have hey added to the end instead. So H is not a vowel, so it's going to be first consonant each word. So first, it's going to become hello, hey, like that. Followed by world, so world, way. I think that's how it works. It's been a long time. I don't think I really did anything like. I think Pig Latin was something that a bunch of always in grade school or so. It was a long time ago. So once we have this, we maybe want to do one more, but this is a good start. So we want to call a function that will sort of just maybe parse through these. Well, let's say the first really big thing is split these by spaces. So if we have a function, so function, we'll call this pig Latin. It's going to take in a string that is type. What do I want to do this? Do I want to do like a reference to a string like that? And I want to return a, I'm not going to return anything right now. I'm just going to print, so print line. Is that it? The string. Just want to make sure I'm passing this correctly, especially since I've lost my I should really like install some Rust stuff. I can't remember which Rust ones to install is the best. I'll install this one. Oh, I need to reload. All right, so we have this. Let's go and nightly tool chain is not installed. Okay, let's install that. So while that's happening, let's go try to run this. Cargo run. Unexpected token. Oh, I forgot the semicolon. Because I put that comment there, I sort of thought I'd already done that. Try it again. Print. Oh, no capital L. That's the problem. Okay, unused variable, but did I get anything written out? No, it didn't look like I did it. So consider using underscore sentence instead because it's not being used. Did I not pass it in? Yeah, I didn't actually call this RLS not installed. Go ahead and install it. I need to call pig Latin and pass it in sentence. Phil, welcome to the stream. What's the exclamation point for? So in Rust, we have normal functions just like this, but then functions require you to pass in like only a very set number of things, and they also require you to only hit like certain types. So Rust also provides kind of like, they're sort of functions, but they call them macros. And the way to determine that it's a macro is this exclamation point right here. And this allows me to send in all sorts of stuff, and the types don't matter. So that is what the exclamation point is for. It does make it interesting, and macros are something that we'll probably be writing ourselves eventually. So let's go and make sure we got this printed out. Yep, so we got our hello world printed out properly. So then the next step would be to loop through and get each word in here. So there's a couple different ways we can say for word in string dot, and I believe it's, can I do split on the space? So if I do that, then I want to print line the word. So let's see what happens now. Okay, so now we have hello and world. So we're getting closer. The idea now is, okay, if I have, if I want to now say, okay, for each of these words, can I grab the first letter? So this is where it gets interesting, because I have a stir. I cannot update these or change these. Also, I believe that this is a borrow. meaning that I don't really, like, this function doesn't own this string, so it can't mutate it in any way whatsoever. But that's fine. We can create another word and return with a string later. But what I really want to do is process this word and maybe like print out each letter of this word. So for word in this, I could loop through again. So for letter in word dot, I could split this by no characters whatsoever. And then print line the letters. And then we have hello world all along with this. It looks like 2 spaces now. But that might actually be like the new line character or something, because when I'm splitting by character, it gets a little bit more interesting. So if I have that, I should now be able to take this first letter and check to see if it's a vowel or not. And for right now, I guess I could like ignore what type it is and just store that off in the, so I want to do this per word, right? So I want to say something like, let first letter, and maybe just like end that right there, because now, first letter, do I have access to that here? Do I want to say, can I put like letter dot 0? I don't think I can get, I don't think it's that easy to get the first thing, yeah. Because I don't think I can get like the index of the first letter. Because that is, well, I might maybe splitting it. I could put them into a, okay, when I split it, I could throw it into a vector, and then I can grab the first one, or I can put it into a tuple to get into the first one. That's a possibility. So I could out here, or maybe right here, say let letters word 0. So I don't think that will work. We can try it. It's a little bit, I think I want letter 0. And Rust is a little bit different with how these things are working. So it gives me an error here. The trait brown standard, string standard ops index integer is not satisfied. A string cannot be indexed by integer. Now, the reason for this is because of how Rust sort of is storing this into memory. It's not really kind of the same way that like JavaScript does it. So it is a little bit different. And I'm thinking maybe what I can just do is store these, like convert the word into a vector. And I kind of want to now take a look at what do I have in string. So let's off to the documentation. Okay, so Rust str documentation. Standard string Rust string. So there are multiple types of strings in Rust. And depending upon whether or not we want it on the heap, which is sort of like this growable area of memory, or whether or not we want it in a stack, which is not growable, like not changeable. So standard slice, standard string. We can maybe slice it out. Because there's this I, pointer, and then the length. So I wonder if I can... You'll stick with Go? It can be really fun with Rust. Specifically the sort of garbage collection, which they say, like, you know, it doesn't have a garbage collector, but it doesn't need one because you also don't need to manually manage garbage either. It happens as long as you write the code correctly. So is care boundary. We don't need that. As bytes, as a pointer, the get mutable one, get checked. So there we can get, I think we could just, chars. Return an iterator over the chars of a string slice. Okay, so if we have chars here, we can sort of see what they're doing here. The char indices. We can get these characters and throw them into a vector. So contains. Okay, so we can see if there is something in there. That's nice to, starts with. But these are all just like Booleans returned, like does it start with this or this? Find, reverse find, split an iterator over the substring of given slice. Okay, so take a look at this. Let v vector, so this is now a vector of strings, lion, tiger, leopard, split off of here, so it becomes lion and tiger and leopard, dot collect. Okay, so I think that's what I want, is split dot collect. Split dot collect. Let's try it. So I don't necessarily need this here. In fact, so this first one is just splitting it by words. And let's say like I have another function here, down here, which I'm gonna call function convert to big Latin. And this is gonna take in a single stir, but it's gonna be interesting like what exactly this passes in. So I'll be curious about that. This is gonna be a word, type reference to a string. I'm not, again, gonna worry about returning anything at this point in time. We could now, for this, convert to Pig Latin and pass in a word. Then in convert to Pig Latin, we want to, well, I can first just make sure that I'm printing the word out, like that I'm actually pulling this in properly. I don't see any errors in here, so that's a good sign. I should just get the words. Perfect. So now what I want to do is convert the words, each one of these, into its own vector. So let characters, so let chars equals word dot split off of each character dot collect. Just like that. Now I can try to print these out. So print line. I can't just print on its own. I'm gonna have to print with the colon question mark, because chars is, you know, it's in memory as a data structure, but not something that normally has a printable thing on it. But I can use the debug print, which is that colon question mark, put over chars. Cargo run. Okay, so cannot infer type for unknown. So I have to tell chars what type you're going to be. So I think we said that this is going to be a vector of type char. So collect the trait bound standard vec char. I'm like losing. It's not satisfied. A collection type cannot be built from iterator over elements of type string. Okay, so you need to be strings. So can I say that your strings like that? I think so. Hey, there we go. So we have hello and world in their vectors here, which, I mean, they sort of look like arrays in JavaScript, and that's kind of what they are, but don't think too hard about it right now. And then we have these sort of other spaces in here, which that's a little bit, it's a little bit sad, but it's also like that's kind of what's going to happen with a lot of these types of things. So what I really probably want to do is create either a new vector and like push things into it and say, okay, we want to go for the first string that's not just empty. The first string that has a letter, and ignore it, like store it to the side, take the rest of the letters and put them into their own new string. So if I say, so we want to either iterate through or ignore this first one. Looks like we can always ignore the first one and go straight to the second one. And I can never remember, can I just put in the characters, like I want position 1? Yep, I certainly can. So H and W there. So what I can do is collect this first letter. So let first letter equals chars of 1. And then I want to get the rest, like the rest of the word starting after the first letter. So I can either iterate through that, or I can maybe, no, it's probably a good idea to just iterate through it. It's nice and simple to do that. I wonder if I can do, so I can do like a for loop. So for index in, we've already got 1, so let's say 2 ... It's gonna be chars dot length, like that. And let's just print line. Chars of I. And we don't need you right now. So this should be everything else, like the hello, and we want to ignore that last white line. So hello, and then we are getting that last little bit of white space. So what I want to do is chars.length -1. And now we're just getting the full letters. So we want to now maybe create our result. So let mute result equals, and it's going to be our string. So it is string from, and it's just going to be an empty string for right now. And I want to push onto result. I want to say result.push and put in chars of I. And I think I'm gonna have to put in string expected char found string. So it wants me to, it needs to convert this to an actual char. Now, can I do .toChar? No method named toChar. Okay, so we have to go find how to convert a string slice to a character. And there is this like function chars, returns an iterator over the chars of a string slice. That might be good. Let me characters equals word chars. You're way too dumb for this. I don't think that you're dumb for this. You're seeing me on chapter 8 of the book, and it does begin very, very, very simply. I think that you can get that. Just start very, very slowly. Give yourself lots of time. So interesting. So this allows us to pull in next. So we can pull in next here and get each of these. That's kind of interesting. But that might not be what I want. Can I convert a string of one thing to chars? Does Rest compile to machine code? Yes. So it is a compiled language. It is not run on its, like, it doesn't run at runtime. Get mute. Get returns a subslice of string. That's probably not what we want. I love how they're using emoji or emoticons as their examples here. So you can see what the length is. Okay, so the syntax reminds you of Kotlin. I've not actually played with Kotlin before. Okay, so what? Oh, it's after 8 o'clock. I'm just realized that I just realized that that's the end. That's gonna have to be the end of my stream because I have to get ready to go to work. Okay, so I think what I want to do is instead of this, I'm gonna end this right here and just say plan is to put the characters into the result string. Result string. Okay, so I'm gonna go ahead and save this here. I love how you're okay with going to work. You must love your job. I do enjoy going to work. I mean, it's, if you don't like where you're working, my suggestion is get out and go do something else, because life is too short to do something that we don't enjoy. Like, that doesn't mean we have to like super love it. It's just, I mean, there's so many people who need our skills, so let's just go and do that. Dazed Head, did you get up very early to stream before work? I do. I wake up at 6 a.m. Which is why sometimes I'm like tired, as I'm like, how am I coding this? What's the time by me? It is 8:05 right now a.m. And and hi, welcome to the stream. We're just about to shut the stream down. So right after I finish here, I'm going to send all of this up to GitHub, and I have links to GitHub in the description, I believe, down below. I think so. And I'm also going to archive this over to YouTube, so that way you can see that. I have a link to YouTube over down below as well. I don't think there's anything else, but if you enjoy this and you want to get notifications when I go live, please hit the follow button. You could also follow me on Twitter and YouTube, which is where notifications for these streams go out, or the archives. With that, I'm going to get ready for work. So I'll see you tomorrow. And click.